As programmers, we should automate our testing process and be able to test our code quickly. Hello everyone! In this video, you'll learn about unit testing and how to get started with JUnit using IntelliJ. In software development, we have to make sure that our programs work correctly. To achieve this goal, we need to test our code carefully and thoroughly. In object-oriented programming, we should have unit test code for every class and non-trivial method. Having rigorous test cases can improve our confidence in the correctness of our code. Test code cannot guarantee that our program is free of bugs, but it can help catch and fix obvious mistakes and improve our confidence. Without unit test code, we typically write a simple program to test our code with different test cases. This ad hoc approach is problematic in several ways. First, we don't have well-documented test cases. Let's review an example in Java's comparable interface video. To test the circle class, we are calling the compareTo method with different circle objects. What we did to try the code is gone as soon as we modified our method calls. Second, if we alter the circle class later, we need to test it again thoroughly. It means that we have to come up with different test cases again, resulting in a tedious process. Using a testing framework such as JUnit can help us automate this testing process. I will demonstrate how to create unit test code for the circle class using JUnit 5 and IntelliJ. It's a good idea to separate the test code from the working code, and it's common to store the test code in a test directory. Let's create a test directory in our project. After that, we need to mark the test directory as test sources root. To generate a template for testing the circle class, click on the class name and then choose Create Test from the menu options. A pop-up window will appear and give us options to select the testing library and methods to test. Here, we choose to use JUnit 5 and press the Fix button to find and include JUnit 5 in our project. Do not press OK too soon, but wait until IntelliJ finishes downloading a list from the Maven repository. When the found and showing results appear, you can click OK. The next step is to choose which methods you want to test. You can write them manually, but IntelliJ can help create a template for test methods. Here, I'm choosing to generate test methods for getRadius, getArea, getCircumference, and compareTo methods. After you click OK, you should get a new test class in the test directory. JUnit 5 uses the @test annotation to indicate that a method is a test method. You may change the method names if you like, but you need to add the @test annotation to all your test methods. When developing test cases, we can start with a simple one, such as testing getRadius, which returns the radius of a circle. We test this method by creating a circle object and then call circle.getRadius method. We can use the assert equals method to compare the expected value with the actual returned value. In this case, circle.getRadius should return 1.0 because the default constructor should create a circle with a radius of 1.0. You can run this test code immediately. Test results appear in the bottom left window where it shows a check mark next to getRadius, indicating that it passed the test case. To show you how a failed test looks like, let's modify the expected value to 1.5. When we rerun this test code, we get assertion failed error, showing the expected and actual returned values are different and the line of code that caused this error. Let's put the correct value back and create another circle with a specified radius. Recall that the circle class has two constructors, one default, the other takes a radius value. so we need to test both constructors. We can use a similar approach to testing the rest of the methods. To test getArea, we create a circle and compute the area of the circle. Let me declare a few variables to make the code more understandable. We can use assert equals to compare the expected and actual value returned by circle.getArea. Let's run the test code to make sure that the getArea returns the expected value. We can continue adding a test case for the getCircumference method. As we add more test cases to the test class gradually, these test cases also serve as documentation for our testing process. Now, let's test the compare_to method to ensure that it works as expected. Recall that compare_to method should return a negative integer if the first object is less than the second one, 0 if they are equal, and a positive integer if the first object is greater than the second object. Here, we create 3 circles with radius values of 1 and 2.5. When we call C1 compared to C2, we expect to get negative integer because C1's radius is less than C2's radius. We can add more assert equal statements to cover other test cases. It's crucial to test all possibilities. In this case, we must call compare_to with at least 3 different scenarios. 1. The first circle is less than the second one. 2. The first circle is greater than the second one. And 3. Both circles have the same radius value. You can run test methods individually, or you can run all test methods in the circle test class. Here, the results show that JUnit ran test methods for compare_to, getCircumference, getArea, and getRadius, and they all passed the test cases. Another test case that we can add is to test for exception. According to the Java API documentation, the compare_to method should throw a null pointer exception if given null. JUnit has a setThrows method that can compare the expected exception with the one thrown by a method call. We expect to get null pointer exception when we call C1 compare_to null. Here, I use a lambda expression as an argument to call the setThrows method. You can think of this lambda expression as an anonymous function. This function takes no parameters and calls the compare_to method with null. Such a call should raise a null pointer exception. Let's try to run this test method. If the expected and actual values are different, the test case will fail and we'll get an error message. For example, if I change the expected exception to be illegal argument exception, which is not true, the test will fail. Let's put the correct exception back to our test code and rerun the test. Finally, let's rerun all test methods to ensure that the circle class passes all test cases. From this video, you've seen how to use JUnit in IntelliJ and write basic test code. JUnit has more features than what this demo covered. You can learn more as you go. What is more important is that you start making unit testing as part of your software development workflow. Coding and testing should go hand in hand. Testing code early makes debugging more manageable and will save time in the long run. Writing and developing test cases helps us understand the expected behaviors of our programs. Test methods should be independent of other test methods and should not make any assumptions about the order of execution when run. Unit test code serves as documentation of the testing process, improves our confidence, and is very easy to run. So, don't wait any longer and start including unit testing in your software development workflow.